This is the Texas STAAR 2013 geometry test, and this is question number 13. It says, a pattern of dots is shown in the 4 figures below. Then it has figure 1, 2 dots. Figure 2 looks like it has 5 dots. Then figure 3 and figure 4. So I've definitely got more dots in each figure. Then it says, if the pattern continues, which expression can be used to find the total number of dots in figure N? Okay, I'm looking for the total number of dots, and I've got figures 1 through 4. I think I understand the problem. I'll cross that out on the bottom. What's my plan going to be? I think what I'll do is I'll count the number of dots in each figure, and I'll make a table for my value of n and my total number of dots. So n was the figure number. It says total number of dots in figure n. So for figure number 1, n equals 1. So here's my table. I'll do n and number dots. Okay, so when n is 1, I've got 2 dots. When n is 2, I'll count them up, 1, 2, 3, 4, 5. When n is 3, I've got 2 rows of 4, so that's 8. And you know what, I just noticed something. Let's see, how can I show this? Figure 1 has these 2 dots here. Oops. These 2 here. Figure 2 still has those 2, but then it's got an extra 3. Figure 3 has those 3 and the first 2, and then it's got another extra 3 here to give me 8. So I've got an extra 3 in figure 2 and then an extra 3 in figure 3. So do I have an extra 3 in figure 4? Yeah, look, figure 4 on top of my 2 rows of 4, I've got an extra 3. So I've got 8 plus 3. When n is 4, 8 plus 3 is 11 dots. So there's my pattern, and I know that that each time I'm going up by 3. So if you remember from algebra, that's kind of like slope. Our number of dots increases by 3, and our value of n increases by 1. So it's kind of like our slope in dots per figure is 3. So I think I could really rule out B and C, because if my slope is 3, I should expect that value of n to be multiplied by 3, not by 2. So let's plug in some values of n and see if they work in our table. So if we think the answer is A, let's plug in 1 for n and see if we get out 2 like we show in our table. So for choice A, that'd be 3 times n is 1, so 3 times 1 minus 5. What is, maybe I could, let's write it in green over here. So I've got 3 times 1 minus 5. 3 times 1 is 3. 3 minus 5 is negative 2. So it doesn't look like it's working for choice A, because I want to get out positive 2 when I plug in 1. Okay, so let's try Let's try choice D instead. So choice D is 3n minus 1. So use green again. Plug in 1 for n. So 3 times 1 is 3. 3 minus 1 is 2. So it works for the first dot, or the first figure. Then we could try 3 times 2. What do we expect to get out? Well, we expect to get out 5. 3 times 2 is 6. 6 minus 1 is 5. 3 times 3 minus 1 is 8, just like we have in our table. And 3 times 4 minus 1 is 11. So it always works. So we're going to go with D as our answer choice. I think we checked it pretty well because we plugged in every single figure that we had. You know, one thing we could do though, we noticed that pattern. What if we had figure 5? Well, we know that we would add an extra 3 dots to figure 4, so maybe it would look something like dot, and then 2 more on top, like that. It's kind of hard to draw accurately on here. So anyways, we'd have 11 plus 3 dots, so for figure 5, we would have 14 dots, and then we can plug that into our formula as well. 3 times 5, 15, 15 minus 1 is 14. There you go.